In this video, we're going to talk about the concept of end behavioral functions. So what end behavior means is, or what end behavior tells us is what happens to the function as x gets very large in the positive and negative directions. So let's look at an example and see what I'm talking about. So let's consider a very simple function f at x squared. So let's say something like this. So now we'll graph it. So we know that's just a parabola pointing up, and we'll put some arrows there. So I'll label the axes. Okay. So what end behavior means is, well, end behavior basically is what do these arrows mean, right? So the arrows tell me that I keep going up and up and up and up. That's what the end behavior is. Where exactly are you going? And then, so this arrow tells me, I keep going up as x gets big, and this arrow tells me what happened, what I do as x sort of goes this way, towards the negative side. So the way we're going to write this is as x gets large, right? So as x gets large, where is this arrow going? So as we move along our axis this way, what's happening to our function? The way we're going to write that is, the way you write as x gets large is as x goes to infinity. So going to infinity just means you're getting bigger and bigger and bigger. So as x gets big, what's happening to y? Or what happens to f at x? So that's what end behavior is. So the answer to that question is, as x goes to infinity, what happens to f at x? So where is this arrow going? This arrow is just going up and up and up and up. So this arrow is also approaching infinity. So that tells me that as x goes to infinity, f at x is also going to infinity. So that's one side of our end behavior. The other side is the other direction. What happens as x gets very, very negative? So as x approaches negative infinity, what happens? To f at x. So the same question. You always have to write this question down. So as x approaches negative infinity, f at x approaches, so where, as we move along in this direction, our x values get very, very negative, where is this arrow going? Again, it's going up and up and up and up. So it is also going to infinity. It just keeps getting bigger and bigger. So if you wanted to write that in one statement, because the end behaviors are the same for both sides, so there's always two end behaviors. Not always, but generally. There's going to be a right-handed end behavior and a left-handed end behavior. The only reason there wouldn't be two is if the function, like there was no domain on one side. So the domain didn't go to negative infinity or positive infinity. But in this case, since they're both the same, it's both positive infinity in for both end behaviors. You could write as x approaches positive or minus infinity, f at x goes to infinity. So you could write it all in one statement by writing plus or minus infinity, just to save yourself some time. But if you don't want to do that, you could just write the two statements. Let's look at another example. So we want to discuss the end behavior of, I'm just going to, so there's my y-axis. I don't know why my y-axis always tilted. But let's say it looks something like that. And then we're going to get a function that does something like this. So in this case, so this is f at x. As x goes to infinity, so this is one side of my end behavior, what is f at x doing? So again, there's an arrow, but this arrow doesn't seem to be going up and up and up and up. It seems to be approaching a horizontal asymptote. And we've seen that before with exponential equations. So there's a horizontal asymptote here. it seems like it's approaching this x-axis. So f at x is actually approaching a, I shouldn't have equals, I should have an arrow. So it's approaching, well, assuming that the horizontal asymptote is right on the x-axis, then it's approaching 0. So it never reaches 0, but it approaches it. So the end behavior could also be, if it's a horizontal asymptote, f at x would be approaching a number. And then as x approaches negative infinity, we have, no, in this case it looks like we're going down and down and down and down. So f at x, if we follow that arrow, looks like it's just getting smaller and smaller and smaller. So it looks like we're approaching negative infinity. So two different possibilities for your end behavior. So it's possible your end behavior is going to infinity. It's possible your end behavior you're going to negative infinity, or it's possible you're going to a number, which would be a horizontal asymptote. Just for one more example, we got some time. You could be doing something like this. Let's look at a trig function. So we know trig functions do this, and they oscillate back and forth and back and forth, and it just keeps going. And then here, back and forth, oscillating. So in this case, as x goes to infinity, what's happening to f at x? Where's that going? Well, as x gets very big, what do? Well, we're just keeping it oscillating, right? It's not going up and up and up. It's not going to a specific number. It just keeps bouncing back and forth between, depending on, if it was a normal sine or cosine. Well, this looks like a sine function. But if it was a normal sine function, it would just be between 1 and minus 1. So f at x isn't really going to anything in particular. It's not getting bigger. It's not going to a number. So we can't talk about the end behavior. So we can't discuss end behavior for this one. Well, we could discuss it. We could say it's bouncing back and forth. But in general, when we talk about end behavior, we mean it's going to a number, or it's just getting bigger and bigger, meaning it's going to infinity, or smaller and smaller, meaning negative infinity. So if it's oscillating like this for a trig function, then you wouldn't talk about end behavior. So in a sense, you could say there is no end behavior. Although I suppose there is, but it's not. It's not a specific number, or it's not infinity.